The chain rule part 1. Although we learned to differentiate a variety of functions, our differential rules still do not enable us to find the derivative of the function. Just kind of to bring this back, actually one of the things, I'm pretty sure I'm going to take it off the quiz, but one of the ones I put on there, actually I put 2x in there instead of just x, which you need the chain rule technically to do. So, but if you still showed the steps right, I would have probably gave it to you, but I just didn't mean to actually put that in there. Because this type of function here, take the derivative of it, you can't make this to the 1/2 and just do the derivative because you have an inside. Okay, so when we have just an x, derivative of x is just 1, so that doesn't really bother us. But now that you have a function inside, you have to take the derivative of that as well. And so when you're doing the chain rule, essentially you're going to see it's another, it's derivative of the function and derivative of the inside. That's what it's going to do. So we'll just get to that. But anyway, so notice that f is a composite function that can be built from a simpler function. So what they do is they use this u method. It's like substitution. They say root u, with u being 2x squared plus 3. And so going back to your f of g of x is f of 2x squared plus 3, which would be that. So just kind of rebuilding it. And when you go back through this, the idea is that we have to make sure that we take the derivative of the inside. So what this basically says in notation is derivative of the outside times the derivative of the inside. So I know this looks a lot harder than that, but that's what it is. So when that previous problem, you would have dropped the 1/2 because it was a square root, minus the 1, so it's a negative 1/2, and then take the derivative of the inside and put it outside of it. That's the form of the chain rule. Okay, so derivative of outside times derivative of the inside. Okay, as we get to more complex situations and different functions, subbing things in with u's will be more helpful. Okay, so overall, just think about that. Here's the famous Lebanese notation you're waiting for, Spads. Okay, so this is dy over dx of that function is the derivative of the inside. So derivative of the outside with respect to derivative of the inside. So dy du means derivative of the whole y, which is the whole function, with respect to the substitution, and then the other one's the inside with respect to x. That's how you would say that. So let's look at this one really quickly. Oh, did you still need that? Yeah, probably. Here, let me pause the video here. All right, so are we good? Janae, are you good? Good. Okay, so this one here, how we would do this is, okay, I'm going to set up with the u's. Okay, you're at the point where you don't have to use u's every time, but we're essentially going to take the derivative of this with u equaling 2x squared plus 3. So u prime is what? What is u prime? 4x, correct. So what's the derivative of this now? We've done that one quite a bit. Yeah, so it's going to end up being, remember, it's going to end up being 1 over 2 root u, right? It'll be on the bottom. And then it's going to be times 4x. Okay, I'll change the u in a second. I kind of mix match there. Let's make it what it is. The u is the 2x squared plus 3. So the 4x just goes on top. Okay, 4 over 2 reduces. This is your derivative. Okay. Any questions? So since it's just derivative of the outside times derivative of the inside. Okay, we have an inside now. We have something that's in brackets, okay, or something that's in a radical. That's your inside. Okay? Question? All right. So this one, they give us the u's already. They say what u is. So they say that we're telling you u is 1 minus 3x squared. So they're just writing it already subbed out. Okay? So what you're going to do is we need to figure out what u prime is. What's u prime? Negative 6x, good. And then we have to take the derivative of y now. Because remember, it's going to be essentially, it's y in this case, y is our f of x, and u is our g of x. So we're going to do f prime of x times g prime of x. We already have g prime of x, it's that. Now we have to find the derivative of this here. That's straightforward, sum difference rule, no problem. So it would be 10u to the 9th plus 5u to the 4th times negative 6x. I'll change these out of u's in a second. But that's the derivative here. The 2 is a constant, so it's gone. And so now you would write it like that. Like that. Like that. These are 3's here, sorry.
Wait, is it 10 times that 1 minus 3x squared to the power of 9?
Yeah. Sorry. Thank you. So we took the derivative of this. We got this. Then we took this. We put it back into the u's and wrote them there. Now we have all our x's. That is the derivative. So now, this is a derivative. That is the derivative. We don't have to worry about foiling things out to the 9th, guys. Don't panic. All we have to do now is, because they told us what they want us to evaluate x at. It says at 1. So all we have to do now is plug in a 1. So,
plug 10 back in and then put 1 in?
no, absolutely not. This is blocked by the exponent. You can't put that in, right? It's just hanging out there. Okay? Well, I see some confused faces. What's wrong? Okay? So again, I took the derivative of this right here. Put that here. Took the derivative of this. So like the confusing part about this is, guys, is that they're essentially, let's just maybe this will help. Essentially, the original is this. That's the original. And they went ahead and put the u's in for you. That's all that's happened. So the u here and the u here. So they said your u is this. And so then we took the derivative of that. That's minus 6x. So then we have that's the inside. This is the outside derivative. Then we just plug these back in like they were. And now we just got to plug in 1 to evaluate.
Why wouldn't you put the derivative of the inside into
Into
it
it for where?
for u?
Because we remember it's f prime of x times g prime of x. This is essentially what u prime is. This is the function with the u's in there. Does that make sense? So we're not plugging it in. The derivative of the inside gets multiplied to the overall derivative. And that's why the minus 6x is out there getting ready to distribute. Okay, so now if I plug 1 in, that's 1 squared, 1 minus 3. So I'm going to get 10 times negative 2 to the 9th plus 5 times negative 2 to the 4th, all times negative 6. Now I have all numbers. I'm evaluating. The x's got replaced by 1's. That's what I just did. I plugged a 1 in. Okay, I don't need to calculate this out. You can use your calculator if you'd like, but this comes up being 30,240. It's quite the slope. Questions? All right. Okay, so what you need to understand is that important special case of the chain rule occurs in other functions. A power of a function supports that f of u is u to the n, where u equals g of x. So we use the power rule, then the chain rule, which is what I've been telling you. So we're essentially taking the derivative of the overall u, like this function, dropping the n, making it n minus 1, and then taking u prime out. Okay, so that's what this is telling you right here. Drop the n, u to the n minus 1, derivative of u, du dx. That's just it, writing it in the power rule combined with the chain rule. We pretty much just did that. Okay, so derivative of y with respect to u, derivative of u with respect to x, because our u is a function of x. Okay, the last one, our u was the 1 minus 3x squared, so derivative of u with respect to x. That's how you read that, okay, in the Lebanese notation. Okay, let's just get to the simple stuff here in terms of doing it. I think you guys are doers more than definition. Anybody writing this down still? No? Okay. All right, so this, essentially my u is that. So like what they just asked you to do, it's just, you don't have to do this. It's u to the 8th. Derivative of that is going to be 8u to the 7th u prime. Now I have to figure out what u prime is. Well, u prime, I come over here. It's 2x minus 1. Now, we have what u prime is. Plug it in. We have what u is. Plug it in. So we're back to x's. 8x, wow, that 2 is awful. X squared minus x plus 2 to the 7th times 2x minus 1. That's the derivative. And you're done. Okay, we're going to do one more, and then we'll finish off tomorrow, or Monday. Okay. All right, gotta start asking more questions in here. This isn't easy stuff. All right, so 1 over cube root of 1 minus x to the 4th. That's not too fun. Okay. So I would write this, if it's me, I'd write it like that. Now we're to, that's my u is 1 minus x minus 4. Okay, I'll do the u's just for practice, but so u is 1 minus x to the 4th. So essentially I'm going to have u to the negative 1/3. The derivative of that is negative 1/3 u to the negative 4/3 u prime. Got negative 4/3, I minus 1 to negative 1/3. U prime, let's figure out what that is. So u prime, 4x cubed negative. And now we can plug everything back in. So you can see that the 1 minus x to the 4th to the negative 4/3 is going to go on the bottom, and the negative 4x cubed will go on top. So it's going to end up being negative times a negative is a positive. That is your derivative. Okay, I'll stop the video if you want to ask questions.